This video is about Objective 7.9. Distinguish between inverse and direct proportional relationships. You should know the slope, you should know the shape of the linear graph, and you should know the relation between the dependent and the independent variable. Please copy this table into your notebook. Let's start by looking at a relationship that is direct and then at a relationship that is inverse. Direct. See here the mass and the volume. Here you can see the mass and here you can see the volume. Take a look at the mass. What happens to the numbers as we go down? They increase. Take a look at the volume. What happens to the numbers as we go down? They increase. A direct relationship is when both of the quantities are increasing together. So as you go down, they increase, and as you go down, they increase. This is a direct relationship. Now let's look at inverse. What happens to the numbers as you go down? If you notice, they increase. Now let's look at the volume. What happens to the numbers as they go down? 500, 300, 200, 100, they decrease. This is an example of an inverse relationship. In direct, both quantities will increase. In inverse, one will increase and one will decrease. Now, let's see what it looks like on a graph. When you graph a direct relationship, you will get a straight line that looks like this. If you notice, the straight line passes from the zero straight up. This is the relationship that you will get on a graph if you have a direct relationship. Now let's look at the inverse relationship. If I were to graph these numbers, the graph comes like this, curve going down. This is an inverse relationship. So we say the slope for the direct relationship is positive. And the slope for the inverse relationship is negative. What's the relationship between what's on the x-axis and what's on the y-axis in a direct relationship? For direct, whatever's on the x-axis, I will just call it A, and whatever's on the y-axis, we will just call it B. If you divide A by B, you will always get a constant. In chemistry, we like to use K as the constant. In an inverse relationship, if you take what's on the x-axis, I will call A, and you take what's on the y-axis, I will call B, and you multiply them by each other, you will always get a constant. A times B will always be K. K is the constant. This is very important. This is what we call the relationship between A and B. Okay, for direct, it's A over B gives me constant. For inverse, it's A times B gives me a constant. Let's solve this example together. Consider the following graph that describes the relationship between total number of words typed by a student with respect to time. Answer questions A to D. Look at this graph. On the x-axis, we have time. On the y-axis, we have total number of words. What is the dependent variable? What is the independent variable? So we want to see how many words we can type in a certain amount of time. So time is the thing that we are changing. So time is the independent variable. You want to see how many words you can write. So total number of words is the dependent variable. To give you a hint, the dependent variable will always be on the y-axis. And the independent variable will always be on the x-axis. That's a hint for you. What is the relation between the dependent and the independent variable? Well, let's look at our graph. Is this a direct or an inverse? Let's go back up here. A straight line passing through the origin is a direct relationship. So this graph is direct. So I can say, if I make this A and I make this B, I can say that A divided by B will always give me a constant K. Is the slope of the graph positive or negative? It's a straight line going up. So this is a direct relationship. So the slope is positive. And the last question is, what is the total number of words typed in 10 minutes? Here's 10 minutes. On the line, we have 500 words. The answer is 500 words. Let's do one more. Look at this graph. This graph looks a little bit different. This is a curve going down. So this is not a direct relationship. This one is going to be inverse. Pay attention to the shape of the graph. All right, the first question, what is the dependent and what is the independent variable? I told you, use my trick. On the y-axis, you will always have the dependent, and on the x-axis, you will always have the independent. So here's the y-axis. So pressure is the dependent variable. Here's the x-axis. So independent variable is volume. Okay? What is the relationship between the dependent and independent variable? Is this a direct relationship or an inverse? A curve going down is an example of an inverse relationship. So if I make this A and I make this B, I can say A times B will always give me a constant K. Question C. Sketch the graph that shows the linear relationship between volume and pressure. The word linear means that they want a straight line. Now, volume and pressure is an inverse relationship. It will not show you a straight line. But they want the graph to be like this. So, if I plot the pressure and 1 over the volume, then I can get a straight line. So the pressure is directly proportional to 1 over the volume. Last question, is the slope of the graph sketched in part 1 positive or negative? Yani this graph. Is the slope here positive or negative? Well, because it's a straight line going up, it's positive. But if the question asked me about this graph, then I would say that the slope is negative.